Okay, so we're going to go through the final test review for Algebra 2. This first question is really meant to be graphed using the calculator, which is I'm going to go in here. Second, there's my, oops, I didn't get the second. Second ln, it's going to give me the e to the negative 2x out of the exponent minus 2. One of the big things here is to realize that that minus 2 at the end of the problem is the horizontal asymptote. It has a lot to do with the range of the graph. The domain of an exponential graph is all real numbers. I use that fancy R for that. But the range is determined by the number added or subtracted at the end. So when I go ahead and graph this, oops, I have to change my view here real quick. Zoom and 6. I get a graph that comes down and dies off. It's an exponential decay, and it seems like it flattens out right here at negative 2. I do need a couple of points, so when I go to the table, really anything that makes sense, like 0, negative 1, would be right there. Okay, and you know, 4, negative 2 isn't actually touching at negative 2. It's just really close. If I look at negative 1, it's at 5.4. So I'm going to go to negative 1 up 1, 2, 3, 4, 5.5. Be about there. And I'll just use a different color pen to kind of get us through here. Alright, whoops. I'm coming down real steep, and then I turn and follow the asymptote from there. Because I'm staying above that dotted line, I can say that the range is y is greater than negative 2. If it's below the line, then y is less than negative 2. Okay, here we go. The next question asks us to write 5 equals 7 to the x as a logarithm. You remember that b to the x equals y is interchangeable with log base b of y equals x. Logarithms always equal the exponent. So this would be log, the base of the exponent was 7, so the base of the log is 7. I know the logarithm will equal the exponent, which was x, meaning the only thing left is my 5 right there. When it comes to expanding or condensing logarithms, we notice there's a 2, a y, an x, and a z. That means 4 different logarithms. So log, I'll write this out 4 times. Okay, the first one is log of 2. Because it came from the numerator, it's positive. The y cubed is in the numerator, so it's also positive. I'll put the y here, and the cube gets to be pulled out in front of the logarithm. So I should have 3 log of y. Now because the x is in the denominator, I'm going to subtract the log of x, which doesn't have an exponent to pull down, so it's just x. And then that z is also in the denominator, so it's also subtracted. I'm going to put that z right there, but it was z squared, so there should be a 2 out in front of the log. And that's our expanded logarithm. When it comes to solving number 4, it starts with the premise that we used on question number 2, that we should be able to rewrite this as a logarithm. Log base 4 of 16,483 equals the exponent 3x minus 2. Now this can go into the calculator, and over here you'll notice the way I go through the calculator. I'm going to press math, I'm going to arrow up until I find log base. My base was 4, and inside of that is 16,483. 16,483. And we get 7.00 equals 3x minus 2. So I'm going to add 2 to get 9 equals 3x divided by 3 to get x equals 3. Was it exactly that? The answer is no, but the 0.00 meant it was really hard to round that differently. You can carry around the extra decimals if you want to make it more exact. We're going to go ahead and graph this graph. To find we need its horizontal and vertical asymptotes to be able to graph this properly. And that'll help us get the domain as well. So horizontal asymptotes, it's either bottom heavy, which means the exponent on bottom is bigger, in which case it's always 0, Or if the x's have the same exponent on top and bottom, we use the coefficients out here. So if this was 2x squared over 1x squared, the horizontal asymptote would be at 2. But because it's a 2x to the first over x squared, makes it bottom heavy, which will force the horizontal asymptote to 0. Vertical asymptotes come from making the denominator 0, which this factors as x and x, and then the 9 could be plus 3 and minus 3, making the vertical asymptotes at 3 and negative 3. So if I come over here to, let's go and use a different color here. Over here at 3, I'll have a dotted line. At negative 3, I'll have a dotted line. And let's not forget the horizontal one is right here at 0. Now the domain is that x cannot be any of my vertical asymptotes. So negative 3 or 3. The remainder of this I'm really going to do just by graph and just get the general shape. So parentheses 2x minus 1 divided by parentheses x squared minus 9. And if I graph that, we should see it broken into 3 pieces. So over here on the left, my graph is living down here. Through the middle, it's zigzagging its way through. Now, in the past, we talked about possibly extra credit sometimes. The top would equal 0 when x is 1/2. You add 1 and divide by 2. What that means is this is physically crossing the x-axis at 1/2. That's not going to happen on the final as an extra credit, but it is a good habit to have developed. And then up here on the top right, we end up with this. Okay, so there's our graph for number 5 with our domain. Number 6 says we're going to simplify this. We're going to do that by factoring. The top is x minus 2, x plus 2. Bottom is x and x. Factors of 6 that subtract to 1 would be a negative 3 and a positive 2. Times, across the top we get x and x. Factors of 21 that subtract to 4 would be 7 and 3. That's a positive 7 and negative 3. Over x plus 7, x minus 7. We notice some stuff cancels. We should end up with x minus 2 over x minus 7. Alright, 7 and 8, we're solving these rational functions for x. And the way we do this first one, because they're a fraction equal to a fraction, we can cross multiply, but you do need to distribute your across the addition. So x times x plus 1 is x squared plus x. Negative 1 times x minus 3 would be negative x plus 3. Okay, so now we have an x squared in our equation, so we need to set it equal to 0. So I'll add x, and then I will subtract 3. X squared plus 2x minus 3 equals 0. X and x, factors of 3 that subtract to 2 would be positive 3, negative 1. So x could equal negative 3 or 1. I do have to check those answers back to the denominator. If it makes either denominator 0, it has to be rejected. In this case, both of those are acceptable answers. Over here on number 8, because there's 3 fractions here, what I'm going to do instead is multiply by the LCD, which would be an x plus 1 times an x. And what that does is, as I distribute, the x plus 1 in the first one cancels out of the LCD, leaving me with just x times x, or x squared. Now here's where a lot of people got into trouble. This 4, it's subtracted. So I'm going to go ahead and do plus a negative 4 so that I distribute properly, because here the x is going to cancel, but I still have the negative 4 times x plus 1. Negative 4 times x is negative 4x, and negative 4 times 1 is negative 4. I had a lot of people on previous tests having a positive there. That equals, and then when I do this last distribution here, the x plus 1 should cancel, leave me with negative 1 times x, or negative x. Because I have an x squared, I want this equal to 0, so I'm going to add x, which gives me x squared minus 3x minus 4 equals 0. x and x. Factors of 4 that subtract to 3 are 4 and 1. I'm going to go negative 4, positive 1. X could equal 4 or negative 1. But if you think about putting negative 1 into the denominator of the original problem, you end up with a 0 in the bottom. So we have to reject that and only keep the 4. Okay, so now we have number 9. We need to find the mean, median, mode, range, standard deviation of the data. All of this we're going to do on the graphing calculator. So we're going to go stat and we're going to edit. I really only care about list 1, so I'm going to clear that, and I'm going to come down and I'm going to start putting these data points in. And so excuse my hand, but I'm going to make this quick. 2, 5, 7, 5, 8, 4, 6, 7, 7, 4, 3, 2, 9, 10, 9, 7, 5, 6, 7, 9, 3, and 2. Now I could find all the, oof, I see I've got a problem up here. My 7 and 5, 9, 7, 5. So I'm going to put a 7 here. I'm going to go down to the bottom and add a 5. If I made a typo somewhere else, you can fix it later. But I'm going to stat, go over to calc, and I'm going to do one variable statistics. It's going to give me some specific information. First, I want the mean, median, mode, the range, and the standard deviation. Those are the values I'm looking for. The mean is given at the very top, 5.77. The range, I'll find in a second, but the standard deviation is right here. They're a funny looking sigma. It's 2.41. Now if I go down, there's the median is 6. The range is the max minus the min. And since I have a 10 and a 2, that makes the range 8. The one that I have to figure out what we have the most of. And so I'm going to go through here and start kind of sorting them. I've got 1, 2, 3 5s. Cross those ones off. I've got 1, 2, 3, 4, 5 7s. So far 7's on top. Looking for something that comes up a lot. The 2's, there's 1, 2, 3. Those aren't enough. 4's, I've got 1, 2. That's not enough. So I'm kind of narrowing it down here. 9, 1, 2, 3, not enough. I think I've narrowed it down well enough to say that the mode is 7. So there's my answer to that question. Alright, number 10, we're going to use our calculator again to do some regression for us. So if we go to y equals, oh sorry, not y equals, but back to stat and edit. Let's clear our list. Actually, I'm not going to clear our list. Dang it. Didn't mean to do that. Alright. Negative 3, negative 2, negative 1, 0, 1, 2, 3. Then in L2 we have 22.8, 11.1, 0.7, negative 4, negative 4.85, negative 2, and 5.1. Now I want to see that, so I'm going to have to turn on my stat plot over here. Second, y equals, and I'll turn that on. The other thing I need to change is my viewing window. I need to make sure it includes the right values. My x's only go to negative 3, so I'm going to go negative 5 to positive 5. My y's, though, go all the way down to negative 5, so I'll go negative 8 maybe, and all the way up to 22.8, so let's go 25. And we can count by 2's or something. And if we graph that, this looks very quadratic. So now when I go to stat and calc, I'm going to choose quadratic. The other options would be linear or exponential are the other options on the test. So if I enter down and calculate, my equation is going to be y equals a, which is 1.999. I'm going to call that 2x squared minus 3.03x minus 3.88. There's my equation. So you have to use the plot in order to tell what type it is. Okay, for the second half of the test, it is all trig based. To start this off, we're going to have to use Pythagorean theorem. 5 squared plus 12 squared equals c squared. 25 plus 144 equals c squared. That's 169 equals c squared. C is 13. Now from this theta's perspective, this would be the opposite side, the adjacent side, and of course the hypotenuse, giving me that the sine is the opposite, 12 over 13, the cosine is 5 over 13, and the tangent is 12 over 5. And I get to flip those for the reciprocal functions. Okay, so number 12, we're going to convert radians to degrees. When we have radians, what we need to do... Okay, so what we're going to do is we're going to take our pi over 180, or pi over 8, sorry, and times it by 180 degrees over pi. That's our conversion factor. And so our pi's are going to cancel here, and we get 180 over 8. Now if we put that into our calculator to get an approximation of that, 180 divided by 8, oh whoops, that's not right, 180 divided by 8, let's try that again, we get 22.5 degrees. 22.5 degrees. Alright, now when we come to doing the sine and tangent of angles without using our without decimals, the idea is that we should be able to go to our unit circle. And remember that the sine is really the y value. And if you look at the y value at pi over 4, which is 45 degrees, if you need that benchmark, the y value is the square root of 2 over 2. If you try to put sine of pi over 4 in your calculator, it's not going to, even if you're in the right mode, it's not going to give you root 2 over 2 as a fraction. It's going to give you some decimal that will feel somewhat random. With tangent of 5 pi over 6, we remember that it's the y over the x. Now I know a lot of you have written these all down, all the tangents down, but if I think about the tangent at 5 pi over 6, that's 150 degrees. Okay, the y value there is 1/2, and the x value is negative root 3 over 2. So first thing I'm going to acknowledge is I have a positive divided by a negative. So I know my answer is going to come out negative. Let's ignore that part. So I'm going to have a negative of 1/2 times 2 over root 3. Because when I divide by fractions, I flip in times. This gets rid of the 2's. Leaves me with negative 1 over root 3. But remember, we're not supposed to leave roots on the bottom. When we pull them up, the price is to leave one behind. So negative root 3 over 3. Will be our tangent there. Again, if you put that in the calculator, it's not going to give you the exact answer. Here, again, we're trying to read the unit circle but backwards. It's asking us where on the circle does the cosine, which is the x, equal root 2 over 2. Well, one of the places is 45 degrees, which is pi over 4. And then if you're looking at your circle and you're thinking about the x stays the same when you move up and down. So if I think about where is this angle right here, it goes all the way around, it should include 315 degrees, or I think that's 7 pi over 4, if I did that right. Those would be all of our answers. Okay, so 16, we're going to do a law of cosines and law of sines combo problem. If we write out everything we have, capital A is 62 degrees, capital B is unknown, capital C is unknown, little a is unknown, little b is 10, and little c is 17. So as I go through and try to solve this, I recognize that I don't have any completed fraction. So I'm going to use the law of cosines, and because I'm looking for little a, I'm going to say little a squared equals little b squared, 10 squared, plus little c squared, 17 squared, minus 2 times my little b times my 17 for c, cosine of big A, which is 62. Now all of this can go into the calculator all at once. So we're going to just go 10 squared plus 17 squared minus 2 times 10 times 17 cosine of 62, and when I do that I get a squared equals 229.38. If I square root both sides, I get roughly 15.1. So little a is going to come in, and let's use a different color here, 15.1. Now that I have that, I can go and do my law of sines to finish the problem out. Now, one of the things we talked about was the law of sines never gives obtuse angles. So if I'm ever in this situation and I have to choose between big B and big C, I'm going to go after big B first. The reason why is because little b is a smaller side, which means it's going to be a smaller angle. So I know I'm not going to get an obtuse angle from this. So when I set up my law of sines over here, we're going to go sine of big B, which I don't know, over its opposite side 10 equals sine of 62 over 15.1. I'm going to have to times by 10, and that'll give me sine of big B equals, let's take the sine of 62 divided by, and I'm going to be real sneaky, I'm going to actually use the exact value and times that by 10. A rounded answer is okay too. To solve this all the way, I've got 0.583. To finish solving it, I really need to do the sine inverse to get big B, and so I'm going to apply the inverse of sine to my answer above and get 35.66, or we'll go 35.7. Now, to find my last one, I'm just going to subtract from 180. Be careful that you use your values correctly, so minus 62 minus 35.7. I could use this value up here, but you've got to be really careful that when you add all this up, you actually get 180. So we're going to say 82.3 degrees. Alright, we've got just a few questions left. We're going to graph the cosine. The amplitude here is going to be 1, and the period would be 2 pi over 2, which is just pi. I'm going to come out 1, 2, 3, 4 marks, call it pi, pi over 2, pi over 4, and 3 pi over 4. And 4 marks to the left to negative pi. Up to 1, down to negative 1. Cosine typically starts up at its positive amplitude, but because this is a negative cosine, I'm going to start down here, then to the axis, up top, back to the axis, and back to where I started. If I backtrack that same process here, I should end up looking somewhat like that. With the sine here, my amplitude is 3, and my period is 2 pi over pi, which is 2. So if I come out 4 marks, 1, 2, 3, 4, that's 2. 2, 3, negative 2. Half of that is 1, then a half, then 3 halves. I want to go down to negative 3 and up to positive 3. Sine typically starts right in the center. I'm going to go up because it's a positive sign, then back to the middle, then back to my, or down to my negative, and back to the middle. I've got to backtrack that backwards. Sometimes we really struggle with the left side, but just remember it should be a repetition of what you did on the right. It should look like one continuous curve that doesn't have a weird bounce in it. Alright, last 2 questions and we are done. These are all about the trig identities. So the cotangent of an angle is the cosine over the sine, and cosine is over 1. This is an example of a problem where I'm going to flip and times by the reciprocal. That's the denominator that I flip. Well, here I see a cosine over a cosine. Those should cancel, leaving me with 1 over sine, which is by definition cosecant of x. Over here, it looks like we've got sort of a Pythagorean thing going on. Tangent squared, cosine squared, plus cosine squared. So I really want to deal with the multiplication first before I look at the Pythagorean identity. Well, tangent squared should be sine squared over cosine squared times cosine squared plus I've got my cosine squared over here. I'm not messing around over here. I'm just looking at this guy on the left. This cosine squared and that cosine squared should cancel, leaving me with sine squared plus cosine squared, which based on the trig identities equals 1. That's all of it. Good luck, and we'll see you in class.